In this section, we are going to explain about the precautions to be made when we use dummy variables in the regression model. The first precaution is that if a qualitative variable has m categories, introduce only m minus 1 dummy variable. In the example we discussed earlier, in order to distinguish three regions, we used only two dummy variables, D2 and D3. Why did we not use three dummies to distinguish three regions? Suppose we do that and write the model as alpha plus beta 1 d1 I plus beta 2 d2 I plus beta 3 d3 I plus ui, where d1 I takes the value 1 for the states in the west and 0 otherwise. If we run the regression, we will not get the result. The reason is that in the setup of where you have dummy variables for each category or group and also an intercept, you have a case of perfect collinearity. That is exact linear relationship among the variable. That is, if we use three dummy variables for all the categories and intercept also, then there will be the case of perfect collinearity. Therefore, we cannot get a results from the regression for running this regression equation model. In our example, since the qualitative variable region has three categories, we introduced only two dummies. If you do not follow these rules, you will fall into what is called the dummy variable trap. That is the situation of perfect collinearity or perfect multicollinearity. If there is more than one exact relationship among the variable, this rule also applies if we have more than one qualitative variable in the model. In our example, since the qualitative variable region has three categories, we introduced only two dummies. If we do not follow this rule, we will fall into the dummy variable trap. That is a situation of perfect collinearity or perfect multicollinearity. This rule applies if we have more than one qualitative variables in the model. For each qualitative regressor, the number of dummy variables introduced must be one less than the categories of that variable. This is the general rule for the use of the dummy variable. Thus, if an example we had information about the gender of the teacher, we would use an additional dummy variable, but not two. That is, if we want to incorporate an additional variable of gender, then create only one variable, not two, taking the value of 1 for female and 0 for male, or vice versa. That is, we can create a variable of one only, not two variables. The second precaution is that the category for which no dummy variable is assigned is known as the base, benchmark, control, comparison, reference, or omitted category, and all comparisons are made in relation to the benchmark category. That is, in the earlier example, we used only two dummy variables, that is dummy for the north as well as for the south. We have omitted the dummy variable for the west. That west category it has no dummy variable, and this omitted variable is known as the base variable, benchmark variable, control variable, comparison variable, reference variable, or omitted category variables, and all comparisons are made in relation to the benchmark category. Therefore, when we estimated the coefficients of other categories, we made it in comparison with the reference category or the benchmark category. That is, in the result we know that this is the benchmark category, then the coefficient of this is in comparison with the reference category, that is beta 1 plus beta 2, and for this south beta 1 plus beta 1 cap plus beta 3 cap. That is the second precaution. The intercept value beta 1 represents the mean value of the benchmark category. In example, the benchmark category is the western region. Hence, in the regression, third important precaution is that the intercept value beta 1 represents the mean value of the benchmark category. In example, the benchmark category is the western region. Hence, in the regression, the intercept value of about 26,159 represents the mean salary of teachers in the western states. And the coefficient attached to the dummy variables are known as the differential intercept coefficient, because they tell by how much the value of the intercept that receives the value of one differs from the intercept coefficient of the benchmark category. For example, the value about minus 1,734 tells us about the mean salary of teachers in the North and North Central is smaller by about $1,734 than the mean salary of about $26,159 for the benchmark category West. If a qualitative variable has more than one category, the choice of benchmark category is strictly up to the researcher. Sometimes the choice of benchmark is dictated by a particular problem at hand. Now, illustratively, we could choose the South as a benchmark category. That is, if more than this example, in the above example, if a qualitative variable has more than one category, as in our example, the choice of the benchmark category is strictly upon the researcher's interest, and the interpretations can be made in accordance. In our example, we selected the West as the category or the benchmark. We can select the other sector also as the benchmark category. It is up to the researcher. In the earlier section, we discussed about the demi-variable trap. That trap can be removed if we use a model which doesn't have the intercept, or if we do not use the, if we do not use intercepted term, then we can use as many categories as available for the formulation of the model. In this model, we have no intercept, therefore we introduced 3 demi variables. That is, here the beta 1 is the mean salary of the teachers in the West, beta 2 mean salary of teachers in the North, East and Central, and beta 3 measures the mean salary of the teachers in South. In other words, with the intercept suppressed and allowing a demi variable for each category, intercept suppressed and allowing a demi variable, we obtain the mean values of the various categories. That is, with the intercept suppressed and allowing a demi variable for each category, we obtain directly the mean value of various categories. The results for the above example is given here without using the intercept term. We have the same result as we have the same result as the this model. This was the results when we used only 2 demi variable. Here the value coefficient values were 26,158 for the West, 24,400 for the North and 22,894. The same results we got for the by disregarding or by the same result we obtained for the model without using the interceptor. This is the way. This is one of the important method for removing the demi variable trap. Then there will be a question: which method is better one in introducing the demi variable? The first condition is that introduce a demi variable for each category. Then we have to omit the intercept one term. The second one is include the intercept term and introduce only a -1 demi variable. These are the 2 options available for. These 2 options will give the same result. Then which one is the better? According to Kennedy, most researchers find the equations with an intercept more convenient. That is, most of the researchers use the equation with intercept and a -1 categories of demi. The reason is that it allows them to address more easily the question in which they usually have the most interest, namely whether or not the categorization makes a difference. If so, by how much? We will get a benchmark and we can make the comparison if we use a -1 category. That is the advantage. Therefore, majority of the researcher uses this the second method, that is include the intercept term and includes only the -1 demi variables. Here we have the models. We discussed about the ANOVA models, and here in the above example, we used only one qualitative variable for 3 regions. But here we are going to use 2 qualitative variables. That is, we considered in the previous example we considered an ANOVA model with one qualitative variable with three categories. In this section we consider another ANOVA model but with two qualitative variables. Here we used two qualitative variables for the estimation of the model. The estimated model was the YA equal to beta 1 plus beta 2. Here in this model we used two separate dummy variables. That is, here D2 and D3 are the dummy variable and D2 shows the marital status, 1 for married and 0 otherwise. The second qualitative term used is the region of residence, that is 1 equal to south and other 0 equal to otherwise. That is, we introduced two variables. In the earlier cases we introduced only one variable for three regions. That is the difference between. We can use these types of dummy variable also. Here in order to show the marital status we used only one dummy variable, married, if married 1 otherwise 0, and for region we have not used two dummy variables. Here we used only one dummy variable D3 for representing the region of residence, equal to 1 if south and otherwise 0 otherwise. In the above example, we have two qualitative variables. Hence, we have assigned a single dummy variable for each category, which is the benchmark category. In the above example, we have two qualitative variables each with two categories. Hence, we have assigned a single dummy variable for each category, which is the benchmark category here. Here, the benchmark category is the unmarried non-south residents. The difference here is that here the benchmark is not married south. Here the benchmark is unmarried non-south. This is the important precautions to be used. In other words, unmarried person who do not live in south are the omitted category. Therefore, all comparisons are made in relation to this category. The mean hourly wage in this benchmark is 8.81. Here 8.81 is the benchmark category for non-married, non-south person. The omitted category, this alpha shows the coefficient for the omitted category, that is non-married, non-south. Compared with this, the average hourly wage of those who are married is higher by about 1.10, 1.10 and 1.67 for the next category. Then it will the actual average wage of 9.91, and by contrast for those who live, an average hourly wage is lower by 1.67 for an actual average hourly. This coefficient is 1.16. This is negative 1.16. Therefore, its coefficient value will be equal to negative 1.67 plus 8.81. That is the coefficient or the average wage for the South married person. In this section, we will discuss about the ANCOVA model. And ANCOVA models are the model in which we uses a mixture of both quantitative and qualitative variables. That is, it will include both quantitative and qualitative variables. This ANCOVA is the analysis of covariance models. In the first example, we used the data set like this. Here we have salary mean, then spending D2 and D3. First we regressed the salary and D2 and D3 here, but we have one more variable here, the public expenditure. That is, if we incorporate a model, or if we introduce a model by incorporating a variable which is quantitative in nature, such models are known as the ANCOVA models. This is the basic difference between the ANOVA model and ANCOVA model. That is, in ANOVA model there will be dependent variable and dummy variables only, whereas in an ANCOVA model, this is the dependent variable, this is independent, this is independent, this is independent. There will be the quantitative variable as independent variable with the dummy variable also. This is the meaning of the ANCOVA models. Then we can introduce the regression model as follows: ya equal to beta 1 plus beta 2 d2i plus beta 3 d3i plus beta 4 xi plus ui, where ya is the average annual salary of the public school teacher in state and xi is the spending on public school per pupil, d2i equal to 1 if the state is in northeast or the north central and 0 otherwise, and d3i equal to 1 if the state is in the south and 0 otherwise. The data on X are given in table, and here also the West are the benchmark category. This is the regression results for that ANCOVA model. Here we have one more independent variable, the public spending on education. The meaning of this model is that as the public expenditure increases by $1, the mean salary of the teacher increases by 3.29. This is the meaning of this model, and the diagrammatic representation is given here. If the slope, the public expenditure, increase in public expenditure is given by 3.29. It is parallel, means we have introduced only two dummy variable, and it is in reference to the reference category or benchmark category. This is about the ANCOVA model. Here, in the case of the ANCOVA model, there will be quantitative independent variables also within the model.